Hey there, Math 210 students. Just wanted to show you an example of a mathematical induction involving divisibility. So this is number 5 on the guided notes. For all n in the integers, n greater than or equal to 0, n cubed minus 7n is divisible by 3. We know we always want to start with our basis step. Right? In this case, in the basis, let's let n be equal to 0, just because it's an easy one to use. You can use any number bigger than 0 if you want to, because that's our domain, but let's just, for simplicity, just use 0. So by substitution, we get 0 cubed minus 7 times 0 plus 3, which is equal to 3. And clearly we know that 3 is divisible by 3. Since 3 times 1 is equal to 3, it is divisible by the very definition of divisibility. So once we've established that the basis holds, so we're going to write thus, our basis step holds for small values of n. Okay. Now we're also going to assume the result holds for all n equals k, where k is an integer. Okay, thus we can say that 3 divides k cubed minus 7k plus 3. And by definition of divisibility, this means that k cubed minus 7k plus 3 is equal to 3 times some integer p, where p is an element of the integers. Right. So that's going to be our first part where we do the basis step and we have the inductive hypothesis. All right. Now we're going to hold on to this because that's what we're going to substitute when we do the inductive step. All right. So we're going to do the rest of this. Okay. So now we're going to let n equal k plus 1. And the goal is to be able to show that n equals k plus 1 is divisible by 3. Okay. So if equals k plus 1, by substitution, n cubed minus 7n plus 3 becomes k plus 1 cubed minus 7 k plus 1 plus 3. All right. Now this is where we have to do the algebra. And don't forget, right, this is one of the most important parts up here because this is our inductive part. All right, so that's what we're going to substitute, even though it's not substitution, it's induction, once we start doing some algebra. All right, so we're going to go back. Now we're going to FOIL this out, all right, and we don't want to do that, but this whole thing, so this k plus 1 cubed, we can FOIL that out. That's going to become k cubed plus 3k squared plus 3k plus 1. And then the rest of it, that's pretty easy to see. That's going to become minus 7k minus 7 plus 3. All right. Now, and again, this is by multiplication. Generally what you want to do is you want to combine like terms. And that's almost always going to be true in every other sort of situation in mathematics. However, there are some times, such as discrete math, where it's important to keep those unique. Right? So what I'm going to do is I'm going to rewrite the problem. And when I rewrite the problem, I'm going to rewrite it so that I have the terms from the inductive hypothesis right next to one another. Okay, so I'm just going to use a commutative and associative property. So we have this k cubed. We have a minus 7k. All right, so I'm just crossing these out as I bring them down. So minus 7k. Then we have the plus 3. And the rest of it I'm just going to bring that down as well. Okay, so I'm going to say plus 3k squared plus 3k plus 1 minus 7. Okay, and that's by our associative and also by our commutative properties. All right. Now I want you to notice that we've set this up extremely nicely, because at this point we can just take and utilize our inductive hypothesis on those three terms, the k cubed minus 7k plus 3. So notice up here that I boxed in red and put the 3 asterisks around. We're just going to use induction, and we're just going to replace that with 3p now. All right, so by induction, now we get 3p, okay, for all of this. So that's just going to come down here, and then we're going to copy everything else down. I'm also going to combine the 1 and the negative 7. So we get plus 3k squared plus 3k minus 6. Okay, so that's by induction, as well as a little bit of computation. I want you to notice that all of the terms now have a factor of 3 within it. So let's factor out a GCF of 3. So we're going to factor a 3 out. We're left with p plus k squared plus 3k minus 6. Okay, and that's just our GCF. And then finally, by integer closure, we know that p plus k squared plus 3k minus 6, that's going to be 3q, where q is going to be equal to p plus k squared plus 3k minus 6. Okay, so that's our closure. All right, so we can say, hence, n cubed minus 7n plus 3 is equal to 3p, which is divisible by 3. By definition of divisibility. Clearly, both the basis and the inductive steps hold, so hence by basis and inductive steps, the original result, or the original formula, or the original postulate, whatever you want to say, the original is valid. All right, so hope this helps. Shoot me an email if you guys have any questions about that.